think it's recording. There we go. All right. All right. Thanks everyone for joining us today. Today we have Jeffrey Palermo. Is it Jeff or Jeffrey? What do you like to go by?
It's Jeffrey.
Cool. Great. So he's going to give us a walk through the Blazor architecture and patterns around it. So it seemed like one of the better title of the different Blazor talks out there. So looking forward to that. We do have our agenda pretty filled up for the next couple of months. So I want to kind of point out that next month we're going to have Paul Sheriff giving a talk on cryptography. After that, in April, Robert's going to give us a talk on Make the Web Faster. I did catch some of this talk. This is actually a really good talk. And Jeff will be coming back in May to give us a talk on Azure DevOps for .NET and fall into the pit of success. So this should be a really good one as well. And also June is taken for Architect Now. That means July on forward is open. Not really sure when exactly we're going to be in person again, but I'm assuming at least through June that we're going to continue to be online. A couple other things to share. Some other events. Microsoft Ignite is the first week in March. So it's free this year and it's online, of course. So you can go ahead and register there, and there's going to be a lot of great content from that. And also at the end of this week, they have these different .NET Confs throughout the year, and they're going to have one that's really focused around Windows itself, so desktop apps and what's new within the .NET 5 and coming in 6 space. So that might be worth checking out as well. For these different .NET Confs, they do record them, and they will put them out on the Channel 9 channel, but also out on YouTube as well. So if you don't catch that, catch the YouTube channel for those recordings and coming recordings. And I also want to share that the full stack user group here in St. Louis does record. They announced their YouTube channel where they have a lot of great content out on their channel as well. And last, I wanted to share that this meetup itself is getting recorded, and soon after I'll post it to our YouTube channel. We have a handful of videos out there from the past couple months, so feel free to check them out. I'm actually going to go ahead and put this particular URL in the chat, and that way everybody has a reference to it. So I don't know if everybody got it the first time around. All right, Jeffrey, I'm gonna go ahead and turn it over to you, and looking forward to this talk. I'll stop sharing my screen.
All right, sounds good. Let me share my screen.
And Scott and I will monitor the chat for questions, whatnot. We typically hold off on more questions at the end, but feel free to, if you see some questions in the chat, to go ahead and address them, or if someone wants to chime in as well.
Sounds good. All right, I believe you can see the screen now.
Sure can.
Okay. Awesome. Well, thanks for having me. I'm so glad that you're here. And my experience with people who attend just various user groups and engage in their own learning on their own time is that you're typically moving faster in your career. You're typically leaders in your team. So kudos to you for doing that. We're gonna dive right in. I've got a lot of content and want to get through it all. A little bit about myself. I had a lifelong hobby of dirt bikes, and so I kind of do the amateur off-road motorcycle racing scene. Of course, that's me in the back, so that's a signal of how good I am. But I'm there, and my boy. Actually, both of my daughters and my boy have now kind of gotten into it. It's just fun. And then we live out in the country to the west of Austin, and so we got some animals roaming around, some longhorn cows, donkeys, and we just refilled our coop with 13 chickens, so that's kind of fun. We just came out of a week of the worst winter storm in the history of modern Texas, I suppose. So we came out unscathed, a little bit inconvenient. We took a trip down to the bottom rung of Maslow's hierarchy of needs. The schools are going to start back up tomorrow. All the teachers are recovering, and the buildings, and so we're all safe and sound. So one of the things that started just a couple months ago is a new video show I put out called Architect Tips. Feel free to check that out, architecttips.clearmeasure.com. It's just short video tips, and we take questions, and sometimes we'll say who the question is from, and other times we won't if the submitter doesn't want to. But that's another resource for you. And this is our agenda on the left-hand side for today's talk. We're going to talk about Blazor architecture patterns, and we're going to talk a little bit about the architecture of Blazor, how it handles memory, and how hub and spoke patterns fit into this new application type, what type of eventing is available and what type of eventing patterns you'll want to put in place, what testing options are available for Blazor applications, and then finally observability in a downstream environment, how to monitor and operate this type of application, because there are some differences. Before I get too far, I like to just throw out this offer. If any, now, while not pertinent to this particular talk, my latest book is .NET DevOps for Azure, and if you are into electronic books, anyone that sends me an email and just says, "Hey, can I have the PDF version?" I would be happy to send you the PDF version of the entire book for you. Just send me an email and ask, and I'd be happy to do that. If you like the print books, then you can go to Apress's website or anywhere books are sold and get that. So I wanted to kind of throw that out there. I'll share my email address at the end if you didn't screenshot this in time. And then I'm also the host of a podcast. It's called the Azure DevOps Podcast, and that's pretty fun. I think we just recorded episode number 130, so going on a little over 2 years now, so that's fun. All right, so let's get into Blazor, and I want to start out with what a development environment might look like for a Blazor application. And this is the top 1/3 of an architecture poster. It's meant to be about 2 foot by 3 feet. And by the way, this is kind of the entire poster. I know you can't read anything there, but if anybody wants the high resolution PDF of the whole poster, just send me an email and I'll be happy to send it to you. But let's talk about the development environment for a Blazor application before we dig in, because so much of the time, the quick starts that I've seen is about, hey, here's how to get this type of feature working in Blazor in this page or that page. But what's important is how to build this type of application, how to test this type of application, how to package it, how to deploy it, and all that. And so there's a lot that is similar, but there are some key differences in a Blazor application from any other .NET 5 application. Blazor does work very, very well with .NET Core 3.1 as well. It doesn't work at all with .NET Framework, so you'll need to be on .NET Core 3.1. Technically, you can go earlier than that, but I wouldn't recommend it, because there was a lot of good features came out around the 3.1 timeframe, and then a lot of performance improvements and stability with the advent of .NET 5 that came out in November. So from a development environment perspective, Blazor is a .NET 5 application type, and more specifically, it is an ASP.NET web application type. And so if you know how to build and test and package and deploy a ASP.NET Core application, then you also know how to build, test, and deploy a Blazor application. We'll get into the two different flavors of Blazor. One is server side, and the other is WebAssembly. And for the server side, it literally is a ASP.NET Core web application deployed, and that can be deployed to Azure App Service. It can be deployed just to regular IIS locally. You can run it via the command line with run the exe, or you can run it with IIS Express. Either one works fine. I find that running it under IIS Express is the most convenient because whenever you make changes, it'll just recycle the process and you can keep it up and running. The WebAssembly version, the model that is probably the best and is catching on the fastest is delivering the web application as a Azure static web app, and then having it call back to app service for the APIs. And given that the WebAssembly version is essentially just a native stateful application that runs in the browser, all of the memories in the browser, all it needs to do is be delivered, and then it calls back to the server. So if you do that, you'll have to have two deployed processes if you use an Azure static web app, and then in Azure App Service for your API application. Of course, you have the option of delivering it with App Service yourself, and you probably don't even need to mess with slicing and dicing the different configurations unless you expect to get high traffic. And there's a lot of applications out there that just need to work. Now, from a deployment perspective, if all you're doing is deploying to Azure App Service, then it's the same way that you've deployed your other applications. And now this is not specifically Blazor, but you'll want to have at least 3 environments. No DevOps environment is complete without at least three environments, because you need at least one of each of the unique types of environments, and there's 3 unique types. Everybody knows production, you obviously need one of those. The next environment back is a manual test environment, and you need at least one of those. So the most common name is UAT, but there's all kinds of different names: staging, sit, test, dit, dev. There's all kinds of names for an environment that you would deploy it to, and then a human would go and do something. All right, you need at least one of those. Pulling back from there, the third unique type of environment that you need, I call the TDD environment. You need a test automation environment. And that is a place to complete the continuous integration portion of DevOps, which is to deploy your application and make sure that it actually deploys and starts up properly, and then run a test suite against the fully deployed instance of the application. Because you got unit tests and you've got component level integration tests that don't need the full application to actually be deployed to a target environment. But then there are just some behaviors of the application that you can only properly test if you've actually deployed it to a representative environment. So that's what the TDD environment is for, and that's a critical part of continuous integration. There's 3 critical parts to continuous integration, and the first part is getting wide adoption actually the second part is getting wide adoption in the industry, and that is a automatically triggered integration build. Whenever you make changes to the source code and you push those changes, you have an automatically triggered process that sets up a build environment, actually converts the source code to a binary code, and then does some asserts, which is essentially running whatever test suites, whatever checks that you have in that integration build process. But the other 2 parts that are not yet getting widespread adoption are the 2 parts that are supposed to sandwich the integration build. And the first one is the private build. And the private build comes first. The private build happens on your own local developer workstation, and it's the signal that you're actually ready to commit and push your changes. And for Blazor applications, that process is not going to be any different. It's just going to be setting up whatever environment. If your application requires a SQL Server database, obviously you need to create that SQL Server database locally, probably with local DB is an easy way to do it, or SQL Express or SQL Server Dev Edition, whichever one you prefer. And then you want to also run your unit tests and component level integration tests locally to make sure that they pass. But then the jumping over the second part of continuous integration, the final part is the first deployment. So we have a change to our source code. We want to know, hey, does it work locally, or am I completely broken? The second stage, the integration build answers the question, combined with the changes of the rest of the team on the master branch, does it still work, or have those combination of changes cause the code to get into an unstable place? All right, and then once all of your integration tests, unit tests passed, it compiles and all that, maybe passes your static code analysis. If you have that in there, the third part of your continuous integration process answers the question, will it deploy? Will it start up? And if the answer is no, well, then your code is in an unstable phase. And so you definitely want to have those three even before you get into deploying down to a manual test environment and then a production environment. So that's the development environment. Really, really clean from a Blazor perspective because it is a new .NET project type. So that's really, really good. And for existing .NET developers, you'll find that very familiar, very, very familiar. Now, from a source code structure perspective, the same rules apply. You want to have one logical version software application per Git repository. Don't try to have two or three. Now, it's fine to have two deployed processes. So if you have the Blazor application and then you have say a backend batch job or an offline Azure function or something like that, that's perfectly fine. That's a part of the same version software application, even though it might have two different deployed processes. Just like a SQL Server database is a separate deployed process, but if it belongs to your application, then it's a part of the same version software application. Now, if you're breaking things up and creating microservices, well, then you have two versioned software applications, and now you need two Git repositories. So some people like to split up the applications on a backend perspective, or even split up the user interface. And if you do that, you need to put them in separate Git repositories and have a separate DevOps environment for each of them because they are separate. And don't forget, if you're going microservices, microservices have to own their own state. Part of the pattern is that it owns its own state, it owns its own data. If you're just splitting off different processes but calling back to the same central SQL Server databases, then you're just decomposing a particular application. You're actually not creating an autonomous service. So that's just something to keep in mind. Blazor is perfectly happy in that world. All right, so now let's talk about the architectural differences. Let's start with Blazor server side first. Blazor server side, what happens when a browser connects is it actually grabs the Blazor client, which is a JS file, a JavaScript file. And then that JavaScript file does a bunch of stuff. One thing it does is it opens up a WebSocket back to the server, and that WebSocket is kept open for the entire life of the application, the user session. And over that WebSocket, lots of different messages pass back and forth. Really, really small binary messages. It's super fast. They pass back and forth, and the web browser is constantly connected to the server. Okay, so it's not a disconnected, stateless environment like serving up web pages. And so let's look a little bit about what that looks like. Now, you can look in the F12 developer tools in any of the browsers, and you can see these binary messages going back and forth. And you can sometimes see little remnants of text where you can see, oh, on render completed. Ooh, I remember seeing that in one of the code files. That's one of the events in the Blazor component lifecycle. Look out for the Microsoft Edge browser Dev Canary Edition, because they are actively working on a better visualizer for these Blazor WebSocket messages, so that you just don't have to try to decipher what's going on, but you can actually see and decipher the information that's going back and forth. It's really important that the users of the Blazor server-side application have pretty good internet connections, meaning low latency, because there is going to be a lot of chatter back and forth from the browser to the web server, and that's fine. They are tiny, tiny, tiny messages, but because there's a lot of them, latency is going to be the biggest differentiation in network performance between the users and the server. And so if you're going over satellite internet or just somewhere where there's low latency. There may be great download speeds, but the latency is slow, then you will be able to perceive sluggishness in these applications. So just keep an eye out for that. When it comes to the WebAssembly portion, it is a complete application delivered to the user's computer. It runs inside the WebAssembly runtime in the browser. It uses the browser's memory, not your server's memory, and then it just does whatever it does. You're probably going to have it call back to APIs that run in a web application that you host, but you could also have it called directly from the user's browser out to other things, because it is a web application. Now, I just said, hey, it could call out to other things. There are limitations on what it can do, and what it can do is basically limited to whatever JavaScript can do, because it does run inside the browser's sandbox. And so it is limited by whatever the browser allows it to do. So if you have a question of, oh, well, would I be able to call out or do this or do that or access this or access that? The rules in what your C# can do running in the browser under WebAssembly with Blazor is the same answer as whatever you could make JavaScript do, because it's running inside the same security sandbox in a browser. So that's kind of the same answer. There's no different answer. So if you have a specific question, you could probably find out by just querying, searching the internet to see if you could do that with JavaScript, and it'll be the same answer. All right, let's go over a few settings for how to deploy a Blazor application in Azure. And I'm gonna start out by talking about server side, because there's some differences, but when you're running Blazor server side, there's actually more unique things than when you're running Blazor WebAssembly. So one of the things that you'll want to just totally ignore is the .NET Framework version. You're not using .NET Framework. You're using .NET Core, .NET 5. And so it just doesn't even use that setting. On platform, if you start out and you've provisioned a free version of Azure App Service, just so you could have zero cost, it's going to default you to 32-bit, and then you are going to run out of memory quick. Blazor server-side applications are memory hungry. And so, if you're under development, it might be fine to use that 1.7 gigs of memory type web instance. But if you're going to have any kind of users on it, you really want to make the minimum that 3.5 gig Azure SKU. And if you're when you're in production, you want to have even a decent amount of traffic, you want to bump that up to the 7 gig web instance. And from experience, you'll find that memory is consumed and the garbage collector cleans up, and you'll see a memory graph that goes up and then down and up and down and up and down. There's a lot of memory allocations just in the normal usage, which is fine. It runs completely in a stable fashion, but just expect that. You need to provide Blazor server-side applications with that healthy amount of memory. Memory is going to be your constraint, not CPU, not I/O. In our experience, it's going to be memory. Go down to WebSockets. The app service free version, again, is going to default to WebSockets off. Actually, it doesn't even support WebSockets. And so WebAssembly uses signalr over WebSockets. And by default, signalr is just going to search and say, hey, do I have a WebSocket? If no, then it's going to fall back to long polling, which is basically just calling back to the server, say, hey, I'm connecting anything. Hey, is there a message? Is there a message? Is there a message? And that is going to generate a lot more traffic on your web server, and is actually going to eat up your CPU. So if you do find that you're bound, check this setting, because long polling uses up a lot more CPU than just having a persistent WebSocket open. So you want to set that on. And then you also want to have ARR affinity turned to on. And that's essentially your sticky session. Now, if you have a super low usage, then this setting doesn't make a difference, because you're never going to have more than one web instance in your app service. But as soon as you get some traffic and say, hey, I need another web instance, or I need to configure some auto scaling, so during certain times I can add a web instance, you want to have ARR affinity set to on, because remember, the browser is getting that connection open to a particular web server, and all of the memory of the state of a user session is being kept in the web server. And so if your user gets routed to a different web server, well, now it just fails and spectacularly blows up because there's no state. So you definitely want to have ARR affinity turned to on. I don't think that there's a reason to have that off. Even if you're only in one web server, you want to prepare to be web farm compatible. All right, here is a sample Visual Studio solution diagram for a Blazor Blazor server-side application. And this is from a real application. It's in the car auction space, and it has two Blazor applications. There's the UI, which is the main Blazor application, and then there's a smaller one which has some admin functionality. And it is using the Onion architecture pattern for dependency management and keeping libraries off to the side. And so that you'll see that there is a core library, and that contains all the business objects, domain model, key interfaces, and then the data access. The data access library actually uses Entity Framework Core, and it references the core project, as opposed to your core project referencing data access. So we also have a unit test project. We also have an integration test project and a acceptance test project. I'll talk a little bit about testing some of the Razor components here in a minute. All right, there's something to keep in mind when we're thinking about dependency management. Now, .NET Core has an inversion control container built in, and it's called the services collection. There are 3 different lifecycle strategies in place: singleton, there is scoped, and there is transient. Now, inside a ASP.NET web application, scoped means that a dependency is going to be alive for the life of the web request, right? But think about what we said about WebSockets. The life of a web request. That's what scoped means in ASP.NET Core. With a Blazor server-side application, we connect, and then we get back a persistent WebSocket connection over, and the original web request never terminates for as long as we have that browser tab open. Okay, so that first web request never finishes. So if scoped means that it's the life of a web request, then in a Blazor server-side application, effectively, it generates the same behavior as singleton, because the web request never terminates. Therefore, a scoped lifecycle is the life of the user session. Now, technically, it's not the same as singleton, because singleton is the life of the process. But from the standpoint of a particular user, it's the life of the user session, which is not what we want. We don't want to grab a data context, for example, or something else, and have the same instance of that object being used for hours and hours and hours, because for however long they leave that tab open and are using it. We want that to be more transient. So keep that in mind. Also, you have a situation where browsers get closed. And so Blazor server side has some logic in it to constantly be cleaning up memory, because it has to detect when a session has essentially gone away. And so abandoned sessions have a 3-minute timeout, and each new HTTP request to the URL, it generates a new session. So in the grand scheme of things, you're going to constantly be seeing abandoned sessions, and then for a period of 3 minutes, that memory is still just sitting around until the cleanup process goes, and then those sessions get cleaned up. So if you have a lot of a lot of objects, a lot of memory being allocated for a new user session, then you may see some significant memory usage if you have people jumping onto the site and then leaving. That is one of the reasons why Blazor server side would be a terrible architectural choice for just a general web application, like a blog or an article site where people search for something, they find it, and they go and they look at it and they leave, because you're allocating a whole bunch of memory for a single web screen view. So not a very good architectural decision for just a regular blog application. All right, let's go back to dependency management. One of the most common cases is using Entity Framework Core and using the DB context. And a lot of people do a class that inherits from DB context. In this case, we have a class called data context that just inherits from DB context, just so you can see. And so in a Blazor server-side application, if you say services.add DB context, effectively that's exactly the same thing as services.add scoped, which that means that the same instance of our data context is going to be used for the entire user's session. No bueno, not good. All right. Now, the Blazor team has realized that this is a really common thing, because the Entity Framework team comes out and says, hey, if you're using ASP.NET, do add DB context, which then translates to add scoped, which doesn't quite work the way you want it to in Blazor server side. So there's a new doc that gives a pattern. Of course, they've clarified that with .NET 5, but just so you know, you want to make sure that you have some pattern, whether it's this pattern or you made your own, that you actually create a DB context factory of some sort. Use a factory pattern, some class that can create your DB context, and then actually register that as transient. And then anywhere in your code, for instance, bid query handler as one of the examples, then you can depend directly on a DB context or whatever your DB context class is called, and it'll come right in because you have that factory logic in the background. And then if you specifically in some code need to control when to reuse a DB context and when not, then you can actually depend on the DB context factory instead, and you have a method, .create DB context, and you can do things like that. All right. Now let's talk about hub and spoke patterns. We have had, probably almost 2 decades where in the industry, if someone said, I'm going to develop a new application, people kind of assumed that it was going to be a web application deployed to a web server and then accessed over HTML and CSS of some flavor. You didn't even have to qualify it. You just said, oh yeah, we have an application. And people just assumed that you meant web application. They would have been surprised if you said, oh, it's a WinForms application or a WPF application or an MFC application or something like that. Okay, so we have had 2 decades where everyone just assumed, oh, it's a web application. That's just become normal. Okay, now we're getting back with Blazor, whether it's Blazor server side or whether it's Blazor WebAssembly, we're getting back to the era of the application type where screens are not stateless as they are in web applications. Now, if you've done significant work with JavaScript SPA frameworks, then you've already gone through this realization that you have screens where every little piece of the screen could have its own life cycle and could live for a long time. And if you did any kind of desktop software, what would now be ages ago, you're going to look at Blazor and you're going to start saying, wait a minute, some of those desktop patterns for event management and state management and eventing on the screen and some of those old patterns, which you stopped using if you moved from that space to the web space, are now going to become relevant again because you have a stateful user interface. Okay, I want to talk specifically about some of those, but let's first talk about hub and spoke in general. Anytime you have a user interface, this is going to be applicable. But when you have a stateful native interface, you want to separate the user interface from the rest of your application. It's always been a good idea to keep your business logic out of your user interface. And the hub and spoke family of patterns enables the user interface to not care about what class deeper into the application actually ends up satisfying the request or the button that the user just pressed on the user interface. And these types of patterns are all over the .NET framework. If you just kind of view the source of ASP.NET and look at the handlers and the modules in the routing engine and the controller factory, you'll see that that's just the normal way of abstraction, and all of the different route handlers and controller factories that are in there are spokes around the hub of the abstraction. So you don't have to create your own pattern, by the way. One of my favorite libraries to use is the mediator library. And then I like to take a class, and as you do with every library, don't take the abstractions that are in the library or the contract that's in the library and pull it into the center of your application. You want to pull in a library, then you want to put an abstraction around it. You want to wrap that library in your own language, and then you want to have the rest of the code in your application use your interface. Don't let the library's language pollute the domain language of your application. So while you love the library, you bring it in and it's useful, you always want to wrap the library with your own code that makes sure that every other usage of that library in your application is using your language and not the library's language. So this is an example of how that might look, where we have a synchronous application bus, which just to use a bus, you don't have to be asynchronous using queues. It can be in memory and use that. All right, so this is what it might look like. This refresh data method, by the way, that's in a Razor component. And all we have to do is create an object that represents the user's intent and pass it into the bus. And on the back end, there are these handler methods that we'll look at that can handle them, such as this. All right, so this is the bus implementation where we just send it, and one of the advantages is that we can do instrumentation around everything that's happening in the application because everything goes through a single choke point. That's the benefit of a hub and spoke pattern. Now let me talk a little bit, and I'm digressing a little bit from Blazor, but no matter what application type you're building, you want to make sure that you're actually using object-oriented patterns. And that might sound funny. We're in 2021. Why am I talking about use object-oriented patterns? Because if you look around at the code samples in so many different places, you'll find that they miss opportunities to use object-oriented patterns, and they end up just using structured programming, which is several more decades old than object orientation. And so let me give you an example. One way to use object orientation to the fullest in your applications is to use an object for everything. Now let's get a concrete example. A user pulls up a screen, they fill in a few form fields or do something, and then they click on a button. Right then and there in the user interface, if we're using object orientation to the fullest, we are going to capture the intent of the user right there behind that button click. And we're going to pass an object into our application. And that object's responsibility is to represent what that user was trying to do. And up there in the user interface, that's where we have the context that we need to fully capture what the user was trying to do. Now, if we miss that opportunity and just take a few data fields from the form fields and then pass them into a method of another class, we'll find down further into the application, sometimes you'll be in that code and say, oh, wait a minute, what was the user trying to do? And you only have a few primitives. That's all you have. So we want to make sure that we're using an object for everything. And when you put it together with a bus pattern, well, now we can, no matter what the user does, we can create an object for what they're doing, what they're requesting. Are they requesting to see data? Are they committing a transaction? We can create an object. Of course, all the properties of that object will have whatever they filled in the form, all the context that's necessary, and then that object can get passed into the application. So one of the patterns that's applicable here is CQRS, command query response segregation, and basically it's a kind of a grouping of objects with having a slate of commands where the user is saying, hey, application, do this, or queries, where the user is saying, hey, I'm searching, I need to see this data, or events, which are, this has already happened. You can't throw an exception processing an event because there's no way to undo an event, because an event is just notification that something already did happen. So you can't stop it because it's already happened. A command could be rejected, and a query is a request in its own right. So when we have everything the user does as an application coming back from the Blazor components, it makes it really, really easy to keep business logic out of the Blazor user interface. All right, and when we're talking about telemetry and knowing what our users are doing, we have objects representing everything that a user tried to do. So we can transform those objects to custom events and custom metrics and send them to APM tools like Application Insights so that we can see some rich telemetry. All right, let's talk about UI eventing now. Now, this UI in a Blazor application is stateful. The objects representing the screen, which is, by the way, is going to be broken up into multiple different objects. This UI is stateful. Okay, we don't want to plan on browser refreshes. Now, when you click on something, maybe a portion of that screen is going to change because the browser is perpetually connected to your server over a WebSocket. And you click on something, whatever you clicked on is going to be sent to the server over that WebSocket, and your C# code is going to run on your server on a server-side Blazor application. It's going to run on the client in a WebAssembly. And then from time to time, you're going to factor a particular screen into many different components. The left-hand side, the navigation, the right-hand side. And so I mentioned bringing back patterns from desktop applications or JavaScript SPA frameworks. That's going to be really important. Let me show you an example of a Razor component that's broken up into different components. So a common pattern of, hey, do I show something or do I not show something? Well, a simple if statement is the pattern that you do. And if the entry, like in a car auction, you might have a car that's entered into the auction. If we load this application and the entry hasn't been loaded yet, well, guess what? We show this. But as soon as the code sets the entry variable to something, Blazor, as soon as any of the variables in the object change, Blazor automatically evaluates this code again, and this if statement is now going to resolve to false, and now we're going to show the details, which is hidden. But I want to show this refresh timer component. So this screen is broken out into a few other components. I collapsed all this because it doesn't matter how to display a car on a screen for auction. We have a refresh timer, and the purpose of this is every 10 seconds or so to cause the screen to refresh so that if there's any new bids, they can be shown there. All right. So let's keep in mind that refresh timer. It is just an empty component that's nothing's passed into it. This is the code of the refresh timer. It has no HTML. It has nothing visible. It is just an object in memory. And on initialized, all it does is start a timer based on whatever we configure the timer to be, if it's 10 seconds or whatever. And then once it triggers, all we're doing is sending to our bus, hey, notify of this object. And the object is refresh timer triggered, which sounds kind of like an event. Okay. So now, just so you know, we have a base class, app components base, where on initialize of the component registers itself with the bus, and this bus is stateful in the user interface. Okay. So we're saying, hey, bus.notify refresh timer triggered. Back on a screen that actually shows information, we are going to implement interfaces, and we're going to have iListeners. You can call it whatever you want. And I'm going to say, iListener of refresh timer triggered, among other things. And so, well, guess what? There's one method I now have to implement in my Blazor component, my Razor component, refresh timer triggered. Well, what does it do? It just calls method refresh entries. And notice all these other events, well, most of the time that's kind of what we do. Hey, let's refresh what this thing is showing. All right. So we're gonna refresh. I might have a screen that's showing 9 different cars in a grid. If I'm on a kind of a browse screen, 9 different cars or infinite scrolling or however, and each of those components might have the refresh time, have the iListener of refresh timer triggered. And if my master page or my layout has the refresh timer component activated, well, then it's going to send out the event every 10 seconds. Event, 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 event. And it's just going to come to all of the components that are subscribed to that event. This is synchronous in-memory eventing. Now, for ASP.NET web pages, this type of pattern makes no sense. It's totally stateless. You don't do this. But this pattern is critical in a Blazor application because you have stateful screens that are decomposed with multiple Razor components. All right, now let's talk about how Blazor server-side components load. And this is not going to be WebAssembly. This is only going to be server-side now, and it loads in some very unique ways. If you'll load a page and open the F12 development tools, there's a performance profiler where you can actually record everything it's doing. Now, if you notice every one of these chunks here, you can see it's e.insert frame and a whole bunch of insert frame. Translate that in your mind to document.addChild. Okay, that's what I translate it in my mind to, because we're adding a new element into some parent into the DOM of the screen. The screen is HTML. Okay, and we're going to load the Blazor server-side JavaScript client, and then everything else comes with these little tiny messages over that WebSocket. And the JavaScript Blazor client is going to be adding all of these child elements. So if you have a browse screen with, let's say, 200 cars up in auction, what happens is, just because of the speed of browsers, you may be waiting 4 or 5 seconds for the screen to show anything in the browser, because it's doing insert frame for 400 cars, and it has to finish before it shows anything. This has nothing to do with Blazor's performance. This has everything to do with the performance of the web browser's DOM in and of itself. It really doesn't matter what browser you're doing, they all do this. And for those of you who've done significant work with JavaScript SPA frameworks, you've seen this behavior because it's exactly the same. Now, what the trick that you do is the same thing that you'll see in a lot of JavaScript SPA and a lot of apps. If you just if you go to Twitter or the Facebook app, you'll see the screens quickly painted with something spinning, and then the real data comes up because you don't just want a white screen. But in Blazor, there's a really, really easy trick, and here it is. If you have a list of stuff, a collection, and you have a tile-based screen, and I'm not talking about grids because the grid components are pretty smart and they'll be able to just show the first bit. But if you're painting a tile-based screen, kind of like showing the tiles of a car auction, for example, there's only so many of those that can fit on the screen anyway, and you're going to scroll down. And so if in this case there were 10 cars that were visible on the screen, and you had to kind of scroll down to see the 11th car and so on. So we don't need to paint every single car before we show anything on the screen. And so what we did is we just say, okay, all the items will take the first 10, and the underscore items to display is what the screen was bound to. And we're going to take the first 10. We're going to tell the screen to paint, and that's what the state has changed. That's kind of a cheater method in Blazor. You say, hey, call the state has changed method, and you will trigger the screen to update. So we take the first 10, we set it to the collection, state has changed, immediately paints the screen, and it's imperceptibly fast. You can't even tell any delays happening with just 10 of them. And then we set the items to display to the entire collection and call state has changed again. And so it paints the rest of them that are below the scroll bar. And so in that, we kind of trick the Blazor framework to show the screen immediately by only taking 10, getting them into the DOM. And now as my eyes are digesting those first 10, the rest of the DOM is actually populated, and we actually bought ourselves a second or a second and a half before any person can even possibly do anything else, like reaching for the scroll bar or hitting a key. So that's a trick that you'll probably use quite a bit when you have lots of items and you're just fighting with the speed of how quickly you can add elements to the DOM in your browser. All right, now let's talk more about this stateful application that you have that's empowered by Blazor. And this particular topic has no difference between Blazor server side and Blazor WebAssembly, but you have a stateful application. And now if there's only one or two users, you probably don't need to worry about this. However, if you have lots of users and things are happening, then you would need this type of pattern. Let me give you the scenario. You're in a car auction, okay? And there's several hundred people watching a particular auction, and you're looking at the screen. Maybe you're looking at the browse screen, or maybe you've clicked into one of the cars and you're looking at more of the information about a particular car in that auction, and you're thinking about bidding, and then somebody else just enters a bid. What should happen? Right? Think architecturally. What would you want to happen? Would you want to wait until they went back and came back to this page or somehow refreshed in order to see it was bid? Would you want the user to enter their own bid only to get an error message that says, oh, that bid level is no longer available, somebody else has already upped the price? No, that's a bad experience. What we want to do is right there as we're looking at that screen, we would want the price of that car to update right then and there. Okay, so architecturally, what we need is the ability to broadcast events across all of the users that are looking at that particular car. Or if I'm looking at the browse screen at all the cars, maybe we want to broadcast an event to all the people that are paying attention to that particular car auction. Obviously, we don't need to broadcast events to every single user of the application because they might be in a completely different part of the country, not even paying attention to the car auction that's going on. And I think it locked up for a bit. Am I back? Can somebody confirm?
You're good.
Okay, cool. Perfect. All right, so broadcasted events. Now, there's a part of this that's built in to Blazor, but you just have to pull it out, and then the part of it you have to do for yourself. Blazor already comes with really, really sweet signalr integration. The actual WebSocket connection that is used to add elements to the DOM actually uses signalr technology under the covers. You don't have to do anything. It's just using it. Okay, that's a detail. You don't have to know about it. It's just using it. But you can piggyback off of signalr already being there by creating a custom hub and registering that custom hub in your program in your program.cs file. And now what you can do is you can broadcast an event to every user who happens to be using your application, and you can use signalr groups to limit it to only certain sections. Like for instance, using a group with, say, the auction identifier to only send the event to people who are actually looking at your particular auction. All right, and this is what that might look like. An iNotification broadcaster, an interface that can be injected into any of your components, and all I have to do is call the broadcast method and send a notification object that inherits from iBroadcastable notification, and then that's it. That's all we have to do. And it calls the hub context.clients.group. You pass in whatever group ID you use, and then instantaneously we can have hundreds of users that are literally have their hands behind their head. They're looking at the screen, and signalr takes care of taking that event and pushing it out to every Blazor's user session, and then every instance of the Blazor application, whether WebAssembly or server side, the new price is visible on the car. Okay, and so that is done by just piggybacking into the signalr the signalr library that's already going to be active, creating a custom hub, and then just a little bit of your own pattern here to create broadcasted events between users of your Blazor application. All right. Now let's talk about testing. There is a framework called BUnit that is actually quite useful, and you can see the syntax here. Now this is an in-unit test fixture. So BUnit doesn't replace in-unit or XUnit. It is kind of like Selenium. It is to be used inside of an in-unit test or inside of an XUnit test. And what it does is enables you to create and instantiate a Razor component just with a few lines of code. And so if we have, like, for instance, the bid dialog is a Razor component inside this auction application. Okay, the little dialog that pops up that can collect, hey, what do you want to bid? Okay, do it. All right, so what we're going to do is to this underscore CTX, it's not shown here, but their BUnit comes with a test context object that can do interesting things. One of them is render the component bid dialog, and we can pass in as many parameters that we want. In this case, the bid dialog needs to know what car entry that we're looking at, and then it also needs to know some authentication information that kind of snipped out for space's sake, and then the route data so we can know what auction that we're on. And so we're going to render the component, and now we have a variable here of iRendered component, and it has some interesting things. We can examine the entire markup that our component rendered, so we can use element IDs or CSS selectors to make sure that some things are present and some things are not present, and just do some. And we can just do some asserts. So the dot should, that's an assert. The dot should here, dot should there. And so what we see is we've rendered the component. We've made sure that the bid button was there. Then we're actually modifying a property because there's this component has an if statement. So if you put an if statement in your Razor component, well, now you have logic. Now you have branching logic, and your test you need to exercise both sides of that branching logic. Okay. Now you want to minimize as much logic in those razor components as possible. You want to try to avoid the if statement. But if you do have an if statement, you need a test that exercises both branches. So we're going to block that entry for sale, use our regular data access layer to update it. And we can either have it be an integration test and go all the way to the database, or we can stub out the data service. It's your choice. We're going to render it again and make sure that the bid button is not there. And in our case, we have a status with a particular message. Okay, so that's BUnit, and it's really, 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 really useful. You want to make sure that BUnit tests are as small in scope as you possibly can. And if you find that there's just no way to get BUnit to instantiate a razor component, you just can't, it just doesn't work. Chances are that razor component is just a spaghetti web of dependencies, and you want to redesign that component and the things that it depends on, because well-factored objects, whether they're razor components or whether they're just a regular C# class, well-factored objects, of which a razor component is one, are easy to get instantiated inside of a test fixture here. All right, let's look at full system acceptance tests. Now, because Blazor is based on HTML and CSS, the Selenium web testing tools work very, very well. And so if you're first in Selenium, you would do it largely the same way. There is one key difference here, and I hope that they will fix this soon. Blazor does not have the same signals that Selenium can pick up on as page-based ASP.NET. For instance, if Selenium clicks on a button and the web browser refreshes on a regular ASP.NET website, then Selenium can immediately continue, because we can just wait for the next load. Well, because Blazor doesn't ever refresh the browser window, Selenium doesn't actually know when it's clear to proceed with the next step. And so you're going to have to invent your own way to either add some sleeps or trigger off of something else. And so you look at this method and it's like sleep, sleep, sleep. Oh, this just makes the full system acceptance test suites just take so long to run, because invariably we're sleeping for longer than we need to. But that is one of the limitations, and I have faith that situation will resolve itself, because it kind of impacts us all. But Selenium as a test tool is going to work very, very well to do your full system acceptance testing on Blazor applications, regardless if it's server-side or WebAssembly deployed. All right, so now let's talk about operations monitoring. I've already said that it uses more memory. It uses a lot more. It uses more CPU than a regular ASP.NET web application, but not terribly. You will need low latency, and you want to instrument what people are doing. The .NET Framework and Application Insights are already going to instrument what SQL Server is doing and what Entity Framework is doing and what all your key dependencies are doing. But that really doesn't tell you important things. For instance, your application's running. It's a car application. Have there been any bids in the last hour? Well, that's kind of an important thing to know. Or has anybody even logged in the last hour? That's an important thing to know. And a lot of developers are used to querying the production database in order to get answers like that. We don't need to do that. Okay, we don't need to do that. And I'll show you in a second. I do want to talk about the version 3 app service instances that were released in November. P1 v3 is twice the power and half the cost as P1 v2. So if you look at your web instances, and if you are still on the old ones that are like P1 v2, you want to get off of that and get onto P1 v3. And Stefan Shakow came on the Azure DevOps podcast a few months back, actually in December, I believe it was. And he clarified for Blazor server-side applications, actually for any production web application, the new P1 v3 is probably the smallest SKU that Microsoft wants us to use. And whereas the previous P1 v2 came out and had essentially 3.5 gigs of memory, the new P1 v3 has 7 gigs of memory. They doubled the memory. Okay. And the S1 is not really meant for production either, but they doubled everything. They made it cheaper. And if you never go below one web instance, you might as well just use a reserved instance for the entire year and get an additional 33% discount that they've introduced. All right, let's talk about how to monitor Blazor server-side applications. There's 2 metrics that are built into the application insights that behave in a very specific way with Blazor server side. And one is server response time and the other is average receiving time. Now, we've already talked about Blazor server side being really, really chatty over that signalr WebSocket connection. And they're tiny, tiny different messages. But what that does is that it creates a lot of different opportunities for the server to respond. So server response time is actually averaged among probably 10 to 20 times as many chances to respond as if it was just a regular page-based ASP.NET application. So because of that, you're going to see a lot faster server response times than maybe you're used to with your other types of web applications. And that's fine, but you want to make sure with that, if the response time is averaging over 2 milliseconds, it needs to catch your eye because the latency is such an important factor and because there's so many messages going back and forth. Once the server starts to have a problem responding pretty much immediately, as in 2 milliseconds, you're going to be on your way to noticeable performance sluggishness. Now, we've seen it get up to 10 milliseconds on average, and it's barely perceptible when using the application, but it definitely shows that the performance of the application is starting to become unstable for the level of user load that's been applied. And the remedy to that, to get it back down to more averaging 2 milliseconds, the remedy to that is just to increase the number of web instances that you have, so that you're spreading the user load across multiple web instances. Now, the average receiving response time, we've seen that as long as that is less than 100 milliseconds, we can't perceive any kind of sluggishness in the application. So that's been another heuristic that we've seen. Now, obviously, because it's possible to run a Blazor server-side application in the same web application as Blazor WebAssembly and ASP.NET Web API and ASP.NET, you can mix all those different flavors. If you have all those flavors mixed in a single running application, then you're going to have to learn what normal means for you in all of these metrics. But if you have an application that is just Blazor server side, then I think that this guidance is pretty good guidance. All right, in your Azure App Service, once you go above one instance, now you're in a web farm scenario. And the setting that we showed you before with ARR affinity, that's going to break you if you have it turned off. Also, if you're using broadcasted events with signalr and you're not using Azure signalr service, then you're not actually going to get all of the events broadcasted. If you're not using the Azure signalr service, then ASP.NET is actually going to start up and run a signalr service in process. And that only works if you're using one web instance because it's in memory, it's in process. And the events are only going to be distributed to the users who happen to be on the same web instance. So in order to get completely broadcasted events across an arbitrary number of instances, and we've seen this be we've seen this work all the way up to 30 web instances with Azure signalr service. It is just absolutely automatic. I mean, we've seen just absolutely insane user traffic cranked up to 30 web instances, bids going crazy, tons of traffic, and the Azure signalr service worked like a dream, broadcasting and events to every single user using the Blazor application. Now, we talked about taking the intent of every user's request, of every button click, of every navigation, whatever the user wanted to do and intended to do, and wrap it up in an object, whether a command, a query, or an event, and then passing it through the application and processing it that way. We also showed that we could translate that into telemetry by just sniffing what was going through the bus. Well, in Application Insights, that can yield some really interesting graphs. Now, if you look at the top right, we're filtering events by certain things. And remember, this is an auction application. That's an example I'm showing you. So let's look at some of them, see if we can kind of figure out what might have happened. Register new buyer command. Maybe there was a new buyer that registered to participate in the auction. Sounds like it. Running totals. Well, I know what it means. It was actually a query to get, how much have I bid so far? How much am I in for? Let's go to the bottom. Submit new add-on command and submit new bid command. Those are both transaction types. And so we have these selected, and we can look over the course of, happened to be last summer, June, July, August, we can see that traffic is generally increasing as more and more auctions, start to use this particular application. At the same time, we have some seasonality. Looks like maybe weekends are more popular for auctions than the middle of the week, okay? But all we had to do was check the box for what events we wanted to pay attention to, and immediately we can get counts. And of course, we can drill in further, but we get this for free just by making sure that our application was object-oriented. Because when there's objects flying around instead of just groups of variables, when there's objects floating around, you can have things that kind of observe every object going through the bus and say, hey, an object is coming through. Let me take it. Let me take the name of it, and let me take the top level properties of it, and let me send it over to Azure Application Insights as a custom event. And then that's it. And then all of these graphs automatically just work. Why? Because we used object-oriented development. All right. And these green check marks across the top, those are release annotations. That's an integration that we have in our Azure Pipelines configuration for deployment to production. Everywhere there is a check mark was a deployment to production. Now, for every deployment to production, there was probably dozens and dozens of deployments to UAT as individual features and whatnot. But there's a check mark. So if some type of event or some type of metric started to go sideways, we can kind of give an indication of, that was right after this particular event. Maybe we had an issue, or, hey, we're trying to solve an issue and the metric got better right after one of those green check marks. Good, it got better. That's what we were looking for. Okay, now Blazor server side also has this concept of an open circuit because we are keeping memory available. Blazor WebAssembly does not, because Blazor WebAssembly's entire world is just inside a particular user's web browser. So we talked about the inversion of control lifecycle of singleton, scoped, or transient. That affects what singleton means as well, because if the process is running just inside a particular user's web browser, well, the life of the process is the same as the life of that user's session. But on Blazor server side, the life of the singleton, the life of the process is until you restart the server. Okay, so based on how you deployed, some of those concepts mean something different. But when you have a Blazor server side, you automatically open circuits. If you're using custom hubs, then you will open up those signalr circuits. And it's the same thing. You will definitely want to keep a count of how many open circuits that you have. Of those, of the connected circuits, how many of those are open, and then how many circuits are disconnected and waiting for their 3-minute timeout before all of the memory gets collected. And the reason it waits 3 minutes is sometimes, whether it's a smartphone or anything else, the network connection can get severed. But think about your smartphone. You go through a dead spot and you have it open, it's persistently connected, and then your signal cuts out, but then it cuts back in like 5 seconds later. Well, you want to reconnect with the server side memory that's already there. And so Blazor has that process to kind of reconnect disconnected clients with the memory that's been set aside for them, but it has a 3-minute timeout. So you'll definitely want to keep track of that. And some of the common things that we look at are the average memory percentage by web instance. We look at the average number of connected circuits by web instance, because a particular user is going to be pegged to a particular web instance. So that's another thing. If you find yourself being overloaded and you don't have auto healing or auto scaling, and you crank up the number of web instances, those new web instances will sit there largely dormant, and you'll have the original web instance or 2 web instances which are overloaded. There is no automatic rebalancing of user sessions. And because Blazor server side uses sticky sessions, you have to do something to intervene in order to rebalance those. And the most foolproof way to intervene is to add more web instances to your app service, and then go to the advanced application restart tool and just essentially restart the web server on the instance that's overloaded. And that'll cause all of those clients to go through a reconnect cycle, and then they'll get distributed to all of the instances that are available. Now, if that instance is not overloaded per se, then you can just wait, and the natural disconnecting and reconnecting of your user base will cause reconnections to be distributed to something. And it'll even out. You just kind of wait 15 minutes and it'll even out. All right. Let's move on. Okay. So this is an example class of what you might write in order to send a custom metric to Application Insights so that you can start tracking how many open circuits that you have. Blazor provides you a circuit handler abstraction, and you can inherit from circuit handler and then register that in the services collection. And then you can do some logic based on a circuit connecting or a circuit disconnecting, which is on connection down. And it could be just as simple as implementing a counter, recording a particular metric, sending it to Application Insights. I talked about wrapping every library with your own abstraction. This is an example of that. iTelemetry Sync, that is an interface that this application owns. The implementation of iTelemetry Sync directly uses the Application Insights SDK, because you don't want to have the Application Insights SDK being depended on in literally every class of your application, because then you would have to say, this is a Blazor and Application Insights application. No, you want to keep it off to the side, because what if you wanted to switch to Splunk or New Relic or Stackify? You want to be able to go to as few number of places as possible. So that's the same guidance as every other library. Wrap it with something, and then you need to own the abstraction. All right, that was a whirlwind all the way through code organization, the architecture, building, testing, monitoring in production. And there's my email address that I'll kind of leave up, so that if anybody wants the book, you can just send me an email or the DevOps poster, and I'd be happy to send those over. And I think, John, back to you if there's any questions.
Yes, I'm looking at the chat and I haven't seen anything pop up yet. You shared a lot of great details and a lot of nice tips there. So Definitely appreciated this talk because, most of the talks out there on Blazor, they're kind of how to, and, there's a lot of content out there around that area. So yeah, this is a talk that I simply haven't seen and when it comes to the Blazor space. So it is awesome.
Thank you. Thank you. Well, there is a lot of good information. And actually, I didn't mention this, but anyone who wants to learn more about the different features and whatnot, I would highly recommend Carl Franklin's Blazor Train video series. Carl is just a very gifted and brilliant teacher in general, and he's tackled all the ins and outs of the Blazor framework. And yeah, there's no need for me to duplicate other people's content. It's covered well in that. But at the same time, I think the architectural elements of the framework and how it behaves differently of other application types that can that can help us make good decisions.
Yeah, I mean, I know most of your talk, is more, I don't say focused, but it kind of got into the aspects of the server side more so than the client side. And you did mention early on that the client side, it's really popular when it comes to static web apps and, kind of treating it almost like a real big, like a client, hitting all these separate services. So overall, are you finding that most organizations are looking at server side in a way first when it comes to their applications, and then maybe having bits and pieces of it client side?
Good question. I think it's too early to have averages, and I certainly don't have any averages or stats of so and so many percent choose this or the other. But I will comment on what forces may cause you to pick one over the other. If you're just getting started on something and you need to get it working, and you know who the users are going to be, then Blazor server side is probably going to be a great choice, because when you know who the users are going to be, then by nature that application is probably not going to be internet scale, because they're either employees of your own organization, or either way is probably less than 10,000 people. But if you don't know who your users are going to be, and you describe them as people ordering pizza on Super Bowl Sunday, if you have a user type as opposed to Jill or Mark or Bubba, then now you're thinking, okay, we could potentially have thousands upon thousands upon thousands of concurrent users. And immediately, if you're going after an internet scale or the potential of that, I would immediately rule out Blazor server side, because you do not want to pay for all of those people's memory and CPU power. You need to be using their computer's CPU power and memory and push that out to the edge. So those are a few rules of thumb just right off the bat.
Okay.
But as far as the programming model about how to make it do X or Y, the programming model is the same, but it's really about what computer's CPU is going to be used and what computer's memory is going to be used.
I'm glad you point out Blazor Train, because I know Carl does get into how you can, share libraries, in a way share libraries, whether you're doing something server side or client side. He kind of provided a pattern there. And, I have posed that question to other people before, to where some people respond to it. Why do you need to in other words, or why do you need to separate those? Why do you need to think go client or go server side? It seemed like, and that's why I kind of want to ask you the reaction of, it sounded like you are more thinking about it. You should think server side and more client side. A lot of other people I've asked, they said, well, it's really, you're going to use both in your solution.
I think that's true. Whole. I think you are going to use both. For example, if you need the quickest path to get a particular screen online because 5 people need a backend admin panel or just to do something, Blazor server side all the way. There's the fewest moving parts. You just Visual Studio, click. I mean, the application writes itself, and you just deploy just like a regular web application to where if you're deploying to app service, automatic. If you already deploy in Docker containers, web application, automatic. But if you that's because you don't care, because you're going to use so little memory and so little CPU, it doesn't matter where it is. But when you're using a greater amount of CPU and a greater amount of memory, well, then that forces you to think about where you want that CPU and memory to be.
Right. There is a question did pop up in chat here. I don't know if you want to address it.
Deployable to Kubernetes and Docker. Yeah. So there's actually no constraints or anything regardless. It is a .NET 5 application type. And so there's no difference in how any other .NET 5 application would deploy to Kubernetes or Docker. Now, I will say that if you are not a current user of Kubernetes, stick with Azure App Service for a little while until Azure gets better Kubernetes tooling. They're working on it. Kubernetes is not for the faint of heart. Now, if you absolutely need the power of Kubernetes, you know who you are, and your organization is making the investment in order to do it because you know why. But if you're just out there thinking, oh, what should I use? Should I use Kubernetes or should I use this? Basically, you should translate that in your head is should I use something that has all of this new stuff that I have to learn, or should I use the thing that I've kind of been using and works? Do the second.
Yeah, good point. All right, well, if there's no other questions, yeah, we could wrap it up here. And you provided like a lot of great content here. Oh, here's one that just popped in. If you want to address that.
Okay, yeah. No cloud deployment, just on a regular server. Well, IIS, boom. If you're running on your own servers, it's going to run as IIS. Either you're going to have a web application that serves up the WebAssembly version, or you're going to use Blazor server side and serve it straight from IIS. You won't be able to use Azure signalr service, but you can install signalr directly on your IIS servers and do it that way. So no limitations that I know of. It's .NET 5 through and through, so it would work the same way any other .NET 5 IIS application would work on your 2012 servers. And 2012 is now 9 years old. I don't have memorized the server cutoff that .NET 5 is going back to. I don't know that by heart.
It's a good point, though.
Fight the fight, get on cloud first before fighting the Blazor fight. Yeah, I tell you what. I mean, in my opinion, once you can get anything on the Azure deployment model and off of a full operating system deployment model, you won't ever want to go back. I mean, there's so many things that you don't have to worry about anymore. Now, there's some applications that have dependencies that where they're just not compatible with app service. For example, if you have barcode scanning in your application and you have that custom barcode font that you've always had to install on a server just to have a custom font, you can't install custom fonts on app service instances. And either you have to refactor that out and modify your application to get rid of that dependency, or you have to fall back one notch from app service and package your application as a container and maybe deploy it to Azure Container Instance where you can install a custom font. So you have to kind of think about what dependencies your application has.
Makes sense. All right, I think we can wrap it up here. It was a great talk.
Awesome.
This recording will be out on the YouTube channel. I'll post a link to it in this month's meetup that we can get to it. And yeah, definitely appreciate your time.
My pleasure. My pleasure.
Jeffrey Scott Spradlin here. I just wanted to say thanks again, man, for coming. We really appreciate it. It's good to see your face, man.
My pleasure, Scott. Yeah, it's been a while, hasn't it?
Yeah, and we'll see you in a couple months too. So.
Right. Looking forward to it.
Looking forward to it.
That should be a good one too. All right. Well, thanks everyone.
Take
care.